Alright, so the first group of theorems is going to be the center theorems. Okay, the first theorem, which in this case I'm going to split it into theorem 1a and theorem 1b. The first theorem says the line drawn from the center of a circle perpendicular to a chord bisects the chord. Okay, the line drawn. The line drawn from the center of a circle perpendicular to a chord bisects the chord. Now, this theorem, it is the main one for the first group, okay? It is one of the main ones for the first group of theorems. Now, when you write the reason for the theorem, your reason must be line from center, then use the perpendicular sign to chord. You don't have to write the full theorem in words. Okay? So based on what are called examination guidelines from the Department of Basic Education, the shortcut reason for that is the one which is in the brackets. Line from center, then use the perpendicular sign to chord. In some cases, some learners might end up writing the word perpendicular in full. It will also be acceptable. Okay? So we prove that OA is equal to OB because they are radii. Then M1 is equal to M2 because that's given. And then OM is equal to OM because that's a common side. Okay? Now, based on this condition, the right angle is that. Okay? The hypotenuse, remember, it is the side which is opposite the right angle. So the hypotenuse is, this is the 90-degree angle, that's the 90-degree angle. So we have got AO and we have got what? OB. So our hypotenuses are the radii. Okay? Our two hypotenuses are the radii. So this hypotenuse, that's the two radii. They are equivalent. Then the side is going to be the one that's common, which is this side here, which is from here to there. That will be our side. So therefore, say triangle OAM is congruent to triangle OBM because of the RHS condition. Once we prove the congruence of the two triangles, we can say, therefore, AM is equal to MB because the corresponding sides of two congruent triangles are equal. And then we are done with the proof. Okay? I have to remind you, the proof is examinable. Okay? You have to memorize it. Right, any questions before I introduce the converse? So any questions?
In the exam, they say join and proof. They just say why.
In an examination situation, they'll give you a diagram like this. You have to do the construction of OB and AO.
So they'll just say, if all areas, they'll say proof.
No. The question will say, using the diagram below, prove the theorem which says the line drawn from the center of a circle perpendicular to a chord bisects the chord. That's all. So you are expected to know everything. That's it. You have to memorize it. Okay? You have to memorize it. Any other question? Yes?
So I was always going to have like a 7 to the 6 for all the cases of the
Yes. 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 Your parents got a letter from the school on Monday through the T6. What? That's not my problem. And that's an inappropriate question. Okay. Theorem 1A, the convex. You go outside and wash your face. Go outside and wash your face. Theorem 1A. That is the convex. Right. In previous grades, I'm not sure whether you were taught what the meaning of that word is, the converse, the last year. Okay. The word converse in geometry means the opposite. Okay. It is a statement that is the opposite of, in this case here, it's a theorem. This is called the converse of theorem 1a. Okay, it is the converse of theorem 1a, which means it is the reverse, okay, or the opposite of theorem 1a. So theorem 1a, which is the original theorem, it says a line drawn from the center of a circle perpendicular to a chord bisects the chord. That's theorem 1a. The converse now, it does the opposite. A line segment joining the center of a circle to the midpoint of the chord is perpendicular to the chord. Now, in this case here, you'll be told that the chord is bisected. In the original theorem, the chord, it won't be indicated on the diagram that the chord is bisected. Okay? So here, there won't be any indication that the chord AB has been bisected. Alright? But it will be indicated that a line was drawn from the center of a circle and that line was perpendicular to the chord. That's theorem 1, the original theorem. With the converse now, okay, the shortcut will be line from center to midpoint of chord. In this case, you'll be told that the chord, okay, is bisected. Okay, it will be indicated. Okay, I know it can be a little bit confusing, but there's a difference when we say if a line is drawn from the center of a circle and if that line is perpendicular to a chord, it therefore bisects the chord. And by saying a line drawn from the center of a circle to the midpoint of the chord is perpendicular to the chord. They look like they are the same, but they are not. Okay? So here, this is the scenario. Okay, I'll go back to the original theorem. To the original theorem, if you want to summarize it, right? If you want to summarize it, it means we can say the line must be perpendicular. If it's perpendicular, then it's going to bisect the chord, which means it's going to pass through the midpoint of the chord. The line has to pass through the center, or it has to be drawn from the center of the circle. And the line must be perpendicular for us to conclude that therefore it passes through the midpoint. Hence, the chord is bisected.
So, but this is the same thing. So,
I'm talking about the original theorem. I'm coming to the converse. I'm trying to simplify the original theorem. The line must be perpendicular, therefore it passes through the midpoint of the chord. That's where this word bisects comes in.
so for the converse, so for the theorem I1, they're saying that it is perpendicular and bisects.
Yes.
But for the converse, they're saying because it bisects, therefore it's perpendicular.
Yes.
So it's difference is what's given first.
Yes. Yeah. The difference is in what's given first. So, in the original theorem, you'll be told that the line passes through the center and it's perpendicular to the chord. Therefore, it bisects the chord.
It's the same theorem, but because it's the theorem, you can inverse it to find the same.
Maybe if you wanna simplify it, you can say it that way. Right? Then for the convex now, the line must be drawn from the center of the circle and it is to pass through the midpoint of the chord. No indication that the line was perpendicular, but it passes through the center of the chord. Because it passes through the center of the chord, we can therefore say the line is perpendicular. Therefore, we will be told that the line passes through the midpoint. Okay? Therefore, the line is perpendicular to the chord. Okay? Any question?
So technically, this theorem here, like the opposite of the other theorem.
Yes, that's why it's called the converse. The word converse means the opposite. Just to simplify, it's an opposite statement, which is related to another statement. Okay, so this is the converse of theorem one. A line passes through the center of the circle, and it passes through the it joins the center of a circle to the midpoint of a chord. Therefore, that line will be perpendicular to what? To the chord. Okay, so now you need to be extremely careful with the two. That is the original theorem and its converse. Right? I'm going to emphasize that as I move. So the reason is that line from center to midpoint of chord. That's the reason for the converse. You use this reason if you see a diagram with a chord that is bisected. So if you see the diagram which looks like this, there is no indication that the angle between the line which passed through the center and the chord is equal to 90 degrees. Then it must come into your head that all is the converse. For the original theorem, the line which passed through the center must be perpendicular to the chord, but the chord will not be bisected. Okay? Yeah, I'm telling you this because it's very important. From my past experience, learners have a tendency of confusing the two. And it's very easy to make a mistake there. Okay? For the converse, the one with any 90-degree angle, but it will be indicated that the chord is bisected by a line which passes through the center, or which originates from the center. For the original theorem, okay, it would indicate that a line that passes through the center is perpendicular to the chord, but it won't be indicated that the chord is bisected. But you have to be aware that that line which passes through the center, which is perpendicular to the chord, is a bisector of the chord. Yes.
So the first theorem proves that bisecting, and the second one proves it's perpendicular.
Yes. So the original theorem proved the bisection of the chord. The converse proved the fact that the line which passes through the center is perpendicular to the chord. Right. Now, I wrote here a simple definition of the word converse. Is a situation, object, or a statement that is a reverse of another. Now, in our case, we will take the statement that is reverse of another. That's a converse. Okay, so I summarize it here. The original theorem 1, line from center perpendicular to a chord. The converse, line from center to midpoint of chord. Therefore, the chord will be indicated as being bisected. Right, then, but we have got any question? Right. Just allow me to just do an example.